Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to give you a code review. Basically, somebody emailed me and they emailed me their code and they emailed me the CSV file, and they were having problems with it and they wanted me to see if I could help them. And this person that emailed me was a high school student, and I did actually ask permission to use the data set, and he gave me permission to use the data set. So I'm not, so he does know that I'm making a video and a code review on this. So he gave me permission to do it, but I'm not sure if it was a homework assignment or if it was a project, because I think he said it was a project. But basically what this data set is the data set is a regression problem, but he was doing it as a classification problem, which is why it didn't work, because he said that he was getting a really high loss and no accuracy. And then so I looked at the code, and then I figured out that it didn't take me a long time to figure out that it wasn't a classification problem. It was, in fact, a regression problem. And it took me longer to have the data set installed on my Google Drive than it did for me to figure out what the problem was. So I installed the data set on my Google Drive. It's called yielddf.csv. And so we're going to do a code review of this. It is going to be a project. It's going to be a project that a high school student is undertaking. And I helped him with the code. I shared the Jupyter notebook with him. So I hope that he'll be smart enough just to take the code that I got as tips for him to use in his own code. And I tried not to change it too much. I tried not to do it the way that I would have done it. I just tried to change it enough so it would work. And then hopefully this high school student will be able to do some more things. There are some things that you could do to reduce the error, such as increase the epochs, because I was in a bit of a hurry, so I didn't use as many epochs as I could have. But that's one thing that I would suggest to do to reduce the error, is to increase the epochs, because that's the thing about deep learning. If you increase the epochs, then it'll keep learning. So that's one thing that you can do. And another thing that you can do is like to experiment with the neurons in the neural network and see if you change the number of neurons, if that will reduce the error as well. So those are some things that can be done to improve the error rate. So the first thing, what we're going to do is, I just called this vegetable yield, and I took the name of the person off of the Jupyter notebook just to preserve his anonymity. So we're just calling it vegetable yield. And as I said, I didn't really do it the way I would have done it. I just used the code that he gave me and tried to correct the errors and just do a few little things. But I didn't want to just do it from scratch, because that's not going to help him if you do it from scratch. I was just trying to pick out where he went wrong. But when you create your Jupyter notebook, the first thing that you're going to do is you're going to import your libraries. So we're going to import NumPy as NP, which creates your new NumPy arrays and undertakes numerical computations. You're going to import pandas as PD, which creates your data frames and process the data. You're going to import sklearn.model_selection train test split. So that's going to split your data into a training and test set. You're going to import TensorFlow, which creates your neural network. You're going to import matplotlib.pyplot_splt, which visualizes the data. You're going to import Seaborn as SNS. That's going to be statistical visualization of data. And then I also printed off what version of TensorFlow he had. And the reason why I did that is because TensorFlow goes through so many changes. You need to know what version it is that you're actually working on. So this CSV file that he sent it to me in an Excel notebook. And so I had to install it on my Google Drive. And because I had to install it on my Google Drive, I had to mount my Google Drive to do it. And one thing I will say is I don't know where this high school student was from, but I think he was on the East Coast somewhere. And the reason why is because I received his email in the early evening, and I replied to his email, and then he didn't reply until the next day in the early evening. So I think he's somewhere in the West, but he had an unusual name. It wasn't your standard English name. So because of his name, I can't decipher what his ethnic origin is because it's not any name that I've ever heard. So, but he sent me, this is his Jupyter notebook that I've made changes to, and it's the CSV file that he sent me that I had to actually install on my Google Drive. So we mounted the Google Colab Drive, and then after that, what we're going to do is we're going to read the CSV file. So df equals pd.read CSV, then content drive, my drive, yield df.csv. And he said df equals df drop in hey. So that's what he wanted to do. He wanted to drop all of the rows of data that didn't have any values on them. And that's not what I did. That's what he did. That's what he wanted to do. So I just left it there because that's one way that you can deal with missing values. Another way that you can deal with missing values is to impute them. But he just decided to drop all missing values. And when he dropped all the missing values, he had 28,242 rows by 8 columns. One of the columns was unnamed 0. So what I did was I said df equals df.ilock, all of the rows, column 1 to the end, and that just got rid of that unnamed column. The reason why is because in Pandas automatically indexes every row of data anyway, and since it automatically indexes every row of data, it was not necessary to have that unnamed row. So that's just what I did to get rid of the unnamed row. We look at the info, you can see area and item or objects, and everything else is numeric. So what he said was the y variable is going to be HGHA yield. And so we look at the y variable, the HGHA yield, and you can see what that is. I personally would have called it target, but he wanted to call it y. And then we did the Y value counts. And so when we did the Y value counts, you can see that there were a number of values where there was only one. And then what I did was I created a histogram of Y. So you can see that there's a histogram of Y there. So that's telling you that it is a regression problem. If it was a classification problem, you would have, I think they call it discrete values of 1 or 2 values or 3 or 4, whatever. But this definitely is showing you that it is a regression problem. And what he had done was he was trying to use a deep neural network as a classification problem, and that's why he wasn't getting any accuracy, because it wasn't working. Okay, so I decided I wanted to get the unique number of values for each column of data. So area, you have 101 values. Item, you have 10 values. Year, you have 23 values. And then average rainfall, millimeters per year, 100 values. Pesticide tons, 1,673 values. And average temperature, 1,831 values. And then what I decided I wanted to get the unique values for the object columns. So for call in DF, if df call.dtype equals object, print call df call unique. So area has all of these different countries where they had crop yields. I know they had United Kingdom, but they didn't have United States. So that's interesting. And then item is telling you what the crop was, whether it was maize, potato, rice, sorghum, soybeans, wheat, cassava, sweet potatoes, plantains, and others, and yams. So that tells you what the crop is. So we decided that what he had done, because he didn't want to encode the object columns, so he just decided that he was going to drop the object columns. But I decided that I wanted to use the object columns in the prediction. So what I did was I encoded them using sklearn.preprocessing ordinal encoder. So ENC equals ordinal encoder for call in DF. If df call.dtype equals object, df call equals enc.fit transform, df call.values.reshape -1 df. So here you can see all of the two object columns have been encoded. So that's good. Decided I wanted to create a heat map to see if any of the columns were highly correlated. So we did a heat map, and you can see that the columns are not highly correlated. But you can see the correlation of the columns here if you want to see what they are. So then I standardized the data, because using a deep neural network, it's best to standardize the data, but you can try it. You can standardize the data and see what your error is. And then you can not standardize the data and see what the error is. And then you can take the best way to do it, because that's the way you're supposed to do it. But you're supposed to standardize the data. So I standardized the data using sklearn standard scalar. Scalar equals standard scalar for call in DF. DF call equals scalar.fit transform. DF calls values.reshape -1 1. And then we've already defined the Y variable. So now what we're going to do is we're going to define the X variable, and X equals DF. So you can see this is your X variable after it's been encoded and standardized. And now what we're going to do is we're going to use sklearn's train test split to split the data set up into training and testing sets. And so you can see that we split it into training and testing sets. So the X train, X test has 6 columns of data, and the Y train, Y test has 0 columns of data. And that's not necessarily the way I would have done it. I would have called it X train, X val, but because it's his work and I was just helping him to tell him where he went wrong, I just left the code the way he did it because it's his work. And I personally, with the train test split function, I would have put that function in the cell where train test split was, and he put that function at the very top, which strictly speaking, that's what you're supposed to do. Like when you import your libraries, you're supposed to import them all at once at the top, but I don't generally do that. I generally import the libraries as I need them, unless they're libraries that I know that I'm going to be using, such as Pandas, NumPy, OS, Matplotlib, and Seaborn are generally the ones that I automatically import, but all of the others I import them at the cell that I need them. So now we've got our Y train, so you can see what the Y train is. And you've got your X train, so you can see what the X train is. And so now what we've done is we've imported the TensorFlow modules that we were going to need. So we imported sequential and load model. We imported Keras layers and dense, and we imported callbacks. So what we did was we created a sequential model, and we called it Vegtable crops. I did units, those are your neurons of 50, and you can experiment with that and see. You can experiment with that and see if you can get a less error if you use more or less neurons. But I just used 50, but you could have used less or you could use more, and then see which value of neurons is going to give you the best accuracy. So the activation is reflew, except for the last layer. So the dense units is 1 because you've got only one output. Activation is linear to let you know that it's linear regression, and the name is output. So we compiled it, and we use loss equals mean squared error. That's your loss function. Optimizer equals RMS prop, but you could use Atom if you want to, and you can experiment with the optimizers to see which optimizer gives you the least error, and metrics is MSE. So now that was compiling your data. Now what we're going to do is we're going to train the data. So we're going to set up for early stopping. I set it up for patience equals 25. History equals model.fit. X train, Y train. Epochs equals 200. You could try more epochs to see if your error improves with more epochs, but I was in a little bit of a hurry, so I just kept it at the 2 epochs. Validation data equals X test, Y test. Batch size equals 32. Callbacks equals early stopping. So that means it'll stop early if need be. Test loss test accuracy equals model.evaluate X test, Y test. So we trained the data, and it did early stopping. No, it didn't do early stopping. So it stopped at 200, So what you could do is you could set it up for like maybe 300 epochs and see if it does early stopping. So obviously it stopped before it had finished training. But as I said, I was in a little bit of a hurry, so I just left it at 200 epochs. But you can try it at 300 epochs and see if the error decreases. And then so what I did was I created a graph to decide the loss, and you can see that the MSC and Val MSC were pretty much the same. I predicted on the X test, and I called it YPRED, and then I checked the error on it. I had an error of 30,965. And then what I did was I plotted the actual values against the predicted values. And it doesn't look too bad. But if you improve your epochs to 300, then maybe the error will improve even more. So I created a histogram of YPRED so you can see what YPRED looks like. And then I created a data frame that shows you the actual value as compared to the predicted value. So that's it. That is it for this code review. So there are a few things that you can try to improve the score, like increase the epochs. That might improve your score. And try maybe a different activation function. Or no, try different optimizer functions, because we used RMS prompt, but you might be able to try Atom and see if you get a better error with Atom. And the thing is the documentation for TensorFlow will tell you about the different activation functions and optimizers that you can use. So you don't necessarily have to use the ones that I used. You can experiment and see if you can get something better. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching this video. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button.